Hello, welcome to Short of Stat classes. So this question number 4 this question is from ISI B.STAT 2022. So the question 4 says that let Px be an odd degree polynomial in x with real coefficients. Show that the equation P of Px is equal to 0 has at least as many distinct roots as the equation Px equal to 0. So first in our case we have to show that at Px equal to 0 this will be has as at least as many as distinct real roots, and same for this P of Px will be equal to 0 and it will also have the same distinct real roots. Okay. So this you have to find. Now let us assume that P of x equal to 0 and alpha 1, alpha 2, alpha 3 up to alpha n is not the degree, it is the n real roots it has. This P of x has n real roots. So we know that range of any an odd degree polynomial that will be y of minus infinity to infinity, right? Range of n, that is all real value, okay. Minus infinity to plus infinity. So let us it can be, so this shows that the graph must cross the x-axis at least once. So it will have it will cross the x-axis at least once. So if this value have P of x1 as the root of alpha 1 and P of x2, then it will be alpha 2 if I consider this in this manner. So P of xn will be alpha of n, so it will have at least a distinct real root. Okay. It may have crossed occur at multiple places, but at least it has a distinct real root at every point in the polynomial. Okay. So this shows that P of x is equal to this, as the equation P equal to x0, it will have at least one real root, you can say. Now to find the equation that P of Px is also 0. So P of Px is equal to 0 and has at least distinct real roots. So this x1, x2, x3, so this xn, all of the roots of this P of Px. So if we put suppose f of P of x3, so P at x3, so it will be P of alpha 3, which should be equal to 0. Why? Because if we consider a general form of polynomial as odd degree, that if we write in this manner, so an odd degree polynomial has the general form of P of x is equal to a k x to the power k plus a k minus 1 x to the power k minus 1 plus this a1 x plus a0 and where k is a odd natural number. Okay, and a of k is not equal to 0. So let's take the limit at the positive and the negative infinity of px, and without loss of any generality we can assume that ak is greater than 0. So we will have this limit x tends to plus infinity. So p of x, it will be limit x tends to plus infinity ak x to the power k, which is nothing but this a of k, limit x tends to plus infinity x to the power k, which is equal to this plus of infinity. Okay, and if we consider at limit x tends to minus infinity, p of x, so write limit x tends to minus infinity ak x to the power k, so it will be ak limit x tends to minus infinity x to the power k, which is minus of infinity. So from the above limits we can see that there will be a value x, value for x, that will be a. Okay, let us consider it a, sufficiently large and negative so that p of a is less than 0, and there will be a value for x, let it call it b, and which is sufficiently large and positive so that p of b is greater than 0. So there exists c which belongs to this a and b such that p of c is equal to 0, and that is our, so this p of alpha 3 will also be 0, and so it will has at least okay, distinct real root, and this is because of that px is of a odd degree polynomial. Okay, so we have to show this equation, so we can, so this px equal to 0 and p of px equal to 0.